Ladies and gentlemen, today we will be exploring automated prompt engineering, which is the future of everything, really. So, automated prompt engineering is the idea that you can automate a prompt by having another AI build the prompt for you. Okay. Now, why would you want to do this? You would want to do this because building prompts is very hard and very difficult and requires an extreme amount of experience or knowledge in a field. So if like for example, uh I was trying to analyze I had to go to a dermatologist to look at this pimple on my arm. But I don't know anything about dermatology. So how would I create a good prompt for dermatology if I didn't know how to build, if I didn't have experience within that field. So there's multiple benefits to automated prompt engineering. I've spoken quite extensively on this topic on automated prompt engineering. But today I would like to introduce to you a new concept that is going to change everything, which is dynamic swarm orchestration. And basically, a little insight into what that is so when you build autonomous agents right now, what typically happens is you have to program the agents to talk to each other. You have to say, oh, you talk to agent B, you talk to agent C, and you talk to agent D, and like it keeps going. Basically, you have to write in all the programs and all the rules of the communication between the agents manually, which we believe is a waste of time. Because why not have these agents dynamically talk to who they believe they should be talking to? For example, if you say, analyze my bank account today, it's not going to be calling on a marketer agent or another agent that is designed to analyze X-ray images. It's going to call on the financial analyst, like it's going to call agents that are most relevant to your activities and to your task. So dynamic swarm orchestration is very powerful because it's basically like building a company or building some organization. For example, when you build a company, you build teams that are specialized for very specific things: programming, marketing, finance, and a vast array of other things. And so we are the first people ever to allow you to dynamically orchestrate an entire team of agents. That is, it could build the agents from scratch, or we have a mechanism that allows you to select, like you just say auto, and then it'll autonomously select the type of swarm you need for your business problem. So if you say, I want to analyze these all multiple documents at once, it's going to choose a concurrent swarm because the swarm will dynamically understand your task or your business problem, and then route your agents to that swarm type. And I'll get into the specifics very soon here. Um, but yeah, basically, we're going to be talking about automated prompt engineering. We're going to talk about dynamic swarm orchestration, which we just mentioned, which basically means that your agents autonomously decide who to talk to next, and that's a game changer because as of now, everything has to be manually programmed in. Okay, you have to decide this agent talks to that agent, and that's a waste of time. You don't want to be doing that. You shouldn't be doing that. Uh, the only thing you should be doing is just giving a business problem and then just them figuring it out, or you giving it like data sources and then saying do this. All this unnecessary complexity just dilutes the fun. And so then we're going to have some examples for healthcare, insurance, HR, and more, in a vast array of other diverse industries. And then we'll be talking about the future of multi-agent collaboration shortly after we showcase how to actually do all these three things. So to get started, just type in pip install swarms into your terminal. That's how you get started with swarms. And yeah, we have an example repository of all the examples that we're going to be running in this. So yeah, we'll be sharing all those examples shortly after this. Um, all right. So again, what is automated prompt engineering? Automated prompt engineering automates the design of prompts. So basically, you can have two agents, one who is going to be doing the main task. So you say like, make me 5 marketing posts for X.com. That's the main task. And then what you can do is you can have another agent. You can have another agent that will write that prompt for that task. And then that agent is specialized just to be writing prompts. Um, or you can have the agent build its own prompt given your task. So if you say, you don't, so because most of the time you have to give your agent the system prompt before you actually can get it to do the task. So, but now you say task, then it'll build your system prompt, and then it'll be specialized to that problem. That the only thing you have to say is the problem that you want to solve, and then it'll specialize. It'll teach itself how to do that at a seemingly reliable level. And so let's dive deeper. Um, so the general flow is like I mentioned. You have a task, right? Goes to the agent. The agent will then build its own prompt, its system prompt, and the system prompt is kind of like the extensive instructions that the agent has. So a task is basically like like a very I wouldn't say simple, but it's like do this, do that. You know, it's like build me 5 marketing posts, analyze this data, create this code, and et cetera, et cetera. Analyze this X-ray image. A task is like one unit of work. It's super small and super compact, and the system prompt is the instructions that you give to your agent. So if you wanted to, let's say, like give you financial stock trading advice, your system prompt would have to be much more specialized and much more extensive than like a 3-4 line prompt. 3-4 lines is actually kind of bad. A system prompt would be like an actual instruction manual, you know, like 5-10 pages even, or even more than that in some cases. So you give it a task. You say, I want you to um, and I want you to create 5 marketing posts for my products on Twitter, and then it'll specialize itself for that input business problem, um, at a very like specialized level. So if you say X marketing, it'll specialize itself to Twitter marketing. You know, what are the best practices to create the best posts on Twitter, and et cetera, et cetera. You can be vague. You can be very vague. And the agent will learn in real time very, very quickly and teach itself and talk with itself to ensure that it is reliable enough to actually run your task. Because when you go into ChatGPT and you just say do this, you just say like do this, do that. Like it doesn't. It's not specialized. It's not specialized for that. You have to specialize it. So if I wanted, let's say like, let's say if I wanted, say, build a prompt for an agent to be a master, say TikTok, build a prompt for an agent to be a master TikTok marketing agent that creates the posts, the copywriting, and the ad and the video outline. Make it extensive and make the instructions. So a very simple primitive example of automated prompt engineering would be saying, build a system prompt for an agent to do this, do that, and then now we can copy this once it's finished and then run that on another agent. But here we're creating the system prompt because if we would have written this ourselves, it would have taken a lot of time and it mostly would have been a waste of time, really. So now we could take this, go into a new page. Then we say, you're the TikTok marketing master agents. And then at the bottom, we give it some hashtags to denote the separation. Then we say, create a marketing post to promote a skincare all natural moisturizer for women. And so now we have an agent that is actually specialized to what we're trying to be doing, which is creating a marketing post to promote a skincare all natural moisturizer for women. And so it creates the copywriting, creates the video outline, and you can make it do anything. But as you saw here, we just created a system prompt for an agent to be a master TikTok marketing agent. Now you can specialize this to yourself. Like, you don't need to do, like, you could do anything with this. You could, let's say. So here we're saying, build a system prompt for an agent to be a master X-ray analysis agent that provides a diagnosis, and a spectrum of diagnosis possibilities given an image and some. Actually, just given an image. Make the prompt extensive, step by step, and use best practices. So here it's creating the actual system prompt for the X-ray analysis agent, and then you can see what it's doing. It's creating the prompt, and this is what a good system prompt would look like. You see, but most people are too lazy to write their own system prompts because it would take an hour anyways. Or you would have to be extremely smart in whatever field that you're trying to do. Like I didn't go to medical school. I didn't go to medical school, and I could analyze more X-ray images in not even 30 minutes than every single X-ray expert doctor on the planet. And that's just how it is. With AI is the greatest force multiplier ever made. You do more things using AI than anybody else could ever use with any other tool. And that's simply just how powerful it is. So with this prompt, now we can, if we had an X-ray image, I could find one. But now this agent, if we give an agent this prompt, it'll be specialized just for X-ray images. So here we're saying image quality assessment. Begin by assessing the quality of the X-ray image. Note any artifacts, motion blurring, or overexposure that may impact diagnostic clarity. You see, like, I wouldn't even think about this. If image quality is sufficient for diagnosis, state the limitations clearly and advise on potential image retakes or adjustments. And then we have number 2. Systematically analyze each anatomical region within the image: bones, joints, tissues. Start from the general observations to specific findings, identifying any abnormalities or deviations from normal structures. Then you have the core diagnostic markers. For each region analyzed, identify core diagnostic markers: fractures, dislocations, osteophytes, joint space narrowing, densities, soft tissue dwelling, like, and a bunch of other stuff that I don't know because I never went to med school. But if you know how to prompt AI, you have basically the culmination of every single profession and job and field of knowledge in this AI that you could talk to, and it'll give you any response. It will give you any type of response that you might be looking for. Like, imagine having to doc to, like, the let's say, look up X-ray doctor salary. Look at that, $344,000. These people are not cheap. You know, X-ray doctors are not cheap. Imagine having to pay someone a shit ton of money to get, like, oh, what is this? Core diagnostic markers. Like, it's unbelievable. But yeah, so this is an example of automated prompt engineering, um, and that's essentially how it works, um, on a simple level. So this is still using ChatGPT's interface. I showed you how you could do this with ChatGPT. That's if you're not really technical, but it is kind of boring because, if you want to, if you know how to program, you can do this in one line of code with swarms. You don't have to say anything. Actually, you can give it a name so it could be better. But here, all you have to do to activate auto generate prompt in swarms, in the actual swarms Python framework, is you literally set this to true, and that's it. You say auto generate prompt equals true, and that's it. That's all you have to do. Then you have to give it a name, and then you have to give it a prompt or the task, and then that's it. That's it'll build the system prompt for you. You don't have to, you could just leave that none. You could leave that none as well. Like, it's pretty simple. And let me show you. So we're gonna load up our little Swarm IDE, and then we're gonna show you an example of how you can actually do this. So this is on swarms. This is I'm gonna make an example. Say DSO workshop AP first example. I will be sharing these resources with all of you shortly after this event has concluded. So do not worry. So here we just have some of the example code again. And then we can remove this because we're not using that. And let's see. We just set that to true. And whoop-de-whoop-de. It'll make the prompts. And again, the flow is here. You give it a task, maybe plus a name, and then the agent will build prompts. And that's the flow. So here, if you say, how can I establish a Roth IRA to buy stocks and get a tax break? What are the criteria? Create a report on this question. It'll specialize itself to creating Roth IRAs. So this is the main input problem. This is the main task. And then this is a new feature that we added so that you can run your agent on your CPUs or GPUs or whatever, really. So that you could just basically choose. And so now if we run this, actually we can also print. So we can print let's see, print agent system prompt. So once this is finished, it's going to print the system prompt so we can see it. So let's run this, see what happens, and then we can get started. This is the workspace directory issue. We're going to run that. Actually, let me clear this up. So we're going to run this file. And then now, like I said, all you have to do to auto-generate a prompt in Swarms is literally turn on one button. I mean, that's really it. See, now it's running, it's booting up. Boom. Would you look at that? So it made the system prompt. This is the system prompt. And then this is the actual document. So here it says, how do we establish a Roth IRA for stock investments? And then we say, the executive summary. This report outlines the steps to establish a Roth individual retirement account, yada, yada, yada. Understanding Roth IRA, key features, tax-free growth, no taxes, tax-free withdrawals of contributions at any time. Earnings can be withdrawn tax-free after age 59 and a half. No required minimal distributions, unlike traditional IRAs, yada, yada, yada. A bunch of, Roth IRA stuff that you're probably not interested or actually very interested because you can invest and not make any taxes, pay any taxes. So, yeah, that's might be interesting to you. But yeah, so that's all you have to do in Swarms. It's in the agent class here, and then you just turn it on, say this is true, and then you don't have to worry about building your own prompts, which would take a lot of time, energy, and other resources that you probably don't want to be wasting. And so after having tens of thousands or even hundreds of thousands of agents building prompts, I can very, very clearly say to you that agents are better at creating prompts than you probably will ever be, because it has seen 10 to 50 times more digital text and information than you have. So it's seen, like, ChatGPT has seen all the information there is publicly on the internet and blogs, books about analyzing X-rays. You, I guarantee, have not. And so that's a pretty significant barrier to entry. And so that's how you generate one prompt. Okay. I'll show you now how to generate multiple prompts for multiple agents at the same time. So here we released our Swarm router not too long ago. And the Swarm router basically is like a very simple interface to just select what type of swarm you want. And so here you can see you build your agents, you give them prompts or not. Actually, we could say something like system prompts, change all occurrences, and then we could just make this none. So now it's not even using these prompts. So the way it works is you give it a name, private equity document analysis form, description, max loops. This is the loops for the entire swarm. So if you put 5, these agents will all run in the flow that you specify that number of times. So I'm going to specify sequential workflow. which is one of the simplest swarms that we have. It basically allows you to like one agent talks to the next agent, then the next agent talks to the next agent. It's basically like how most companies work as of now. Most operations are sequential in nature. And so here you could see that. And then here we have a very lovely feature which basically allow you to, just auto generate the prompts for multiple agents. And so you just set this to true at the swarm router class, and then all these agents, so we have here 5 agents, will all have their own system prompts autonomously generated, so that we don't have to do that manually. And so imagine if creating one prompt took an hour for you. What if what imagine how many hours it would take for you to create 5 or 6 prompts. It would take around 5 hours, and that's even if you stay on target for 5 6 hours just creating prompts like a maniac, which you're probably not, because you're probably gonna do something else unless you just really like building prompts, which there are some people like that in the world, but there's not that many. At least I have not met too many, and I build prompts all day myself. So it's like auto prompt engineering is like the holy grail of AI. It truly is. Because if you don't prompt your agents or your swarm of agents correctly, it will simply not do anything that you tell it to do. And so if you say like do this, do that, and you don't say how to do it, it won't do it good enough. And then you get upset, and then you'll be angry, and you say this AI is stupid. Um, and that's simply just not the case most of the time. It's because you just didn't know how to prompt it. And most humans have a problem with communication, especially now with digital devices and things like that. I don't think people used to communicate a lot more effectively in the 90s and the 80s and then maybe the 70s, 40s, like just any time before the 2000s. um I think people back then were much better communicators than they are now. Because now we spend a lot of our time inside, and like we just like our brains are not communicating as effectively as they did in the past. So if you turn this on, auto generate prompts true, and then you give it a task. So you say, where is the best place to find a template term sheet for Series A startups? Provide references and provide links and references. And so what it'll do is take the task, bada boom, it'll take this, and then it'll take its name, and then it'll build a system prompt from the name in the task. So let's try to run this and see what happens. We're going to run this file. Okay, we got an error from a new feature I was trying to add. I haven't pushed my. I'm still working on a major update for swarms. So you see? Oh, we have another error. Let's see. We're gonna run that again. What's going on? Ha! I see the problem. So it's not sequential workflow, but just sequential. Let us see. Yeah. Well, that's what I figured. All right, let's see what's going on here. Hmm. Let me look for something. So if we change this to concurrent, it'll work. Yep. You see, it just ran all those agents all at once. Boom, 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 boom. There's a problem with the sequential workflow there. I gotta fix that. So it answered our question, which was how many loop? Okay, there's only one loop. It answered our question, which is where is the best place to find template term sheets for Series A startups? Provide links and references, and then it gave us these results from every agent in the group here, which is the data extractor agent, summarizer agent, financial analyst agent, market analyst agent, operational analyst agent. And it says NVCA, the National Venture Capital Association, and yep, we got a whole lot of references here. Venture Capital Association, Startup Lawyer, a blog by Yokum Taku offers a range of startup related resources, including a template term sheet. Fenwick and West, a law firm, offers a range of startup related resources, including a template term sheet, etc. Does anybody have any questions this far in this presentation? Let me know. So I've shown you now how to automate the design of one prompt, which is again simple. You just turn auto generate prompt equals true in the agent class, which is this, and then to generate multiple prompts, you can do that at the swarm router level, which takes in multiple agents and can manipulate multiple agents all at once. And that's what's happening here. It's telling each agent you should generate your own prompt. And so that's what's happening here. We can also try this again for well, we could do another example for healthcare. So we see healthcare APE example. So now we could tell cursor. Now we say specialize this agent in Swarm for medical diagnosis of cancer cancer treatment for cardiovascular. So Cursor is really fun because it could do like simple things like this. Like this would have taken me a long time to do without Cursor. So yeah, so now we have a couple of agents that are semi specialized for, you know, analyzing cardiovascular cancer and providing treatments. So here the cursor gave some system prompts, but these are still trash. Like you are a medical data extraction specialist focused on cardiovascular cancer cases, and it's just super short, super bad, which is not good. Again, if you want your agent to give you like super high quality outputs, the only way to do that, the only way to have really, really good outputs is by specializing the agents and configuring them for your specific business problem. So we have patient data extractor, we have the diagnostic analyst, treatment planner, research analyst, treatment monitor. Now we can give some input data. So here we have the cardiovascular cancer diagnosis form, and then here we can change it to say mixture of agents, and then we could also generate the prompt. So now we can have the agent think of a task. So we say, what would be an example task for this? Create a patient profile with symptoms to treat. So now it's going to make a synthetic patient example so that we can run the agents on this task. So we have John Doe, persistent chest pains and pressure, worsening over past 3 months, and then a lot of symptoms. So we're going to copy this. Now we have that. And then now we're going to run it. And so it's going to autonomously generate the prompts for all these agents here. And we'll see in action. Auto generating prompts, generating the prompts, yada, yada, yada. And now we have our entire plan. We have our treatment plan from all of the agents. So based on the provided patient information and test results, the diagnosis is a primary cardiac tumor, likely angiosarcoma. I don't know how to say it. Given the characteristics seen on the cardiac MRI, it's also predicting it's 4.2 centimeters. Location right atrium, extending into the right ventricle. Possible local invasion as suggested by the CT scan. Using the TNM staging system for cardiac tumors, the staging can be estimated as T2, tumor size is greater than 2 centimeters, and or local invasion, and then a bunch of other stuff that we cannot understand because we're not doctors with 12 or 13 years of experience. But the point here is well, extremely well presented because we were very short and brief on exactly what it is that was going on here. Like we didn't say exactly what type of cardiovascular cancer. And we also didn't give these agents their props. They have a simple description, really. You analyze latest clinical trials and research papers on cardiovascular cancer treatments, and that's it. If you wanted a good prompt, this would have to be around like 15, 20, 30 lines of pure instructions, um, which we autonomously made. So we had them made. We didn't do that because that would have taken a lot of time. And so this is just a very simple example of autonomously generating prompts. So it's available in a couple of places. It's available in the agent class here. Again, you turn it on with this setting. All right. And then it's also available in the swarm router. So you just turn this on as it is here. Where is this? Auto generate prompt equals true. And then that's it. That's all you have to do. Maybe give the agent a name. If you give it a name, it'll do much better. And then you just give it a task, and then it'll specialize itself for your task. And that's that. Now, does anybody have some ideas they would like to see with autonomously generated prompts? Could be anything. Let me know. We have a comment from Max saying the auto-generated prompts are too general. Can you include a knowledge base to generate prompts for each agent? Yes. So if well, yes, they are general because you're not the idea is to be as vague as possible. So like you just say what you want, you give it a task, and then if you do have documents, though, if you have like PDFs or CSVs of data, and you give that to the agent, it could build the prompt around that as well. You see, the more documents and the more data you give the agents, then the better the more specialized the prompt will be. Because ideally, like you shouldn't need to build a prompt. The prompt should be there, like it should be dynamically made for the best possible output given your inputs. So you have inputs, you have outputs, then those inputs will become outputs in some way. So if your inputs are good, hopefully you'll have good outputs. And so, yes, Max, if you do provide documents or a knowledge base, it will use that data to make the prompt better. Is the stream really low resolution for anyone else? Is anybody having a low resolution issue? Now? Is it better now? I think it's the streaming platform. But let me know if you can see, like, if you could see the text. Or I mean, I can make it bigger if you wish. But yeah, auto like autonomously generating prompts is still very new. It's still very infant. Um, and pretty soon, like there will be like I don't think humans will be writing prompts anymore, really, because building like agents are much better prompt engineers than humans because they've seen the entirety of the internet. Humans have not seen the entirety of the internet, and thus it is hard for humans to be building prompts. So let me know if you would like to see any ideas to test the auto prompt generation capabilities, um, for any use case. Could be, healthcare, marketing, anything. The idea is for it to be as vast and as encompassing as possible, while still being extremely specialized and precise when it's time to actually run the agent. So if not, if if you do not have some ideas to test APE, then I'll be getting into DSO, which is dynamic swarm orchestration, which is the future of AI. A lot of people keep talking about AGI, and like AGI is such a buzzword now. It's really sad because um a lot of people still think it's on the way, but we've already had AGI for a long time. GPT-4, I mean, like the first GPT-4 is AGI. It's a better programmer than 90 something percent of all human programmers. It's a better X-ray diagnoser than most human X-ray diagnosers. It is literally better than humans in almost every single capacity that you could probably imagine. That is pretty general. Now there will always be improvements that you can make to this generality. Okay, AGI is very basic. It's very simple. It means general intelligence. That doesn't mean how fast is the general intelligence available. Like how fast does it take an AGI to learn something? This is fundamentally different than, an artificial general intelligence that learns over longer periods of time. So there is a spectrum of definitions, a spectrum of capabilities, for this keyword AGI. But that's kind of like the first step in AI. The first step is like you have Adam and Eve, right? Like Adam is GPT-4, then I'd say Eve is like Claude or something, which is a weird analogy. But there's only the this has been an era of individual AIs. These AIs are mostly individualized, which is fun and all. Adam and Eve had their own little garden, and they were just running around and having fun all day. But at a point, or some time, the humans and AGI and AIs alike will evolve to have a society, a group of people, a community. Like Adam and Eve went to massive cities like New York, companies being built, countries being built. Like the United States as a whole is much grander than just two people, Adam and Eve, running around a forest. And so this what you're looking at right here, this phrase, dynamic swarm orchestration, is the first pass ever proposed to dynamically enable agents to decide who are they going to work with in their own swarm. And I fundamentally believe that this is the final stage of AI ever. This is the final stage of evolution for an AI, because you can have, like super basic neural networks, which are basically, like, in comparison with humans, unconscious, like monkeys. They're like monkeys. They're like primates for AIs, like RNNs, CNNs, like the more robotic forms of AI. The second type of AI would be about, you know, semi thinking models like GPT-2, GPT-1. And then after that, like the intelligence scales a little bit. Then you have GPT-3, which is like a semi capable, maybe child, maybe a 4-year old or something. Actually, I wouldn't even say, maybe say it's like a 10-year old. And then finally you get to GPT-4, which is an AGI. I'd say that's like a 40, 50-year old. Um, because it's seen a lot of information, but yet it's still a little bit precise if prompted correctly. Most people say GPT-4 is not AGI because they don't know how to prompt. And prompting, doesn't matter if you have a general intelligence or super intelligence. If you don't know the right questions to ask and how to ask them, then you will not get the outputs you want. And then you will be dissatisfied and you'll be frustrated. And so I keep saying that time and time again. It's kind of funny. But dynamic swarm orchestration is the stage after AGI. It's after ASI because those are singular. Artificial super intelligence is only one AI. And while that might be fun and all, there's still only one AI. It can still fundamentally do only one thing at a time, which is kind of useless, really. But if you have a swarm, you could do multiple things at once. If you have 50 AIs, you can do 50 things at once. If you have 100 million AIs, you can do 100 million things at once. Where you and you could not be able to do that if you just had one AI. So this is like the final stage of evolution. You go from one AI to AGI, then ASI, and then now finally you have a swarm, which is multiple AIs that communicate and work together, just like humans. Like the primates, like 100,000 years ago. Well, I wouldn't say they're primates. I'd say like prehistoric humans, like the Neanderthals. They were basically like GPT-3s, like just running. Actually, no, actually no, they were like GPT-2s. They were like GPT-2s running around, just like ooh, food or forest, uh, water, nice. They were like very primitive. But then when they started to evolve with the ability to communicate, then like these primates, these prehistoric humans, are now building things like fucking Apple and Nvidia, and they're building super cool things, fusion reactors. And that's only a glimpse of what's possible with collaboration, because collaboration is necessary for all species to survive, because not a single individual in this species has all the skills and all the resources that is needed to survive. For example, when you order food from a restaurant, the food wasn't, grown at the restaurant, most likely. If it is, I would like to go there. But for most restaurants, a food has to come in from somewhere else, which is driven by a truck driver, which is then farmed by some guy in the middle of Mexico who's been farming this particular food for 50, 60 years. And so we as humans, we depend on so many people because they have skills and resources that we ourselves do not have. And AIs will also have this problem because they cannot be doing multiple things at a time. And while they do learn faster than us, it will still take time for them to learn new skills and have experience that the other agents in whatever specialization have. So, what exactly is dynamic swarm orchestration? So, at a very simple level, you can look at this as, let's say, Bank of America org chart. It's basically an org chart. An org chart defines who is talking to who. So here we have a board of directors. This board of directors is going to talk to the general manager. It's going to talk to the board risk committee, audit committee,
compliance committee, and then it goes down and down and down. Or we could look at another one and say, JP Morgan. All right. No, wait, no. Yeah, so that's a little bit better. So dynamic swarm orchestration is basically automating the design of this chart based on who is the best possible candidate for this job. Why is Jamie Dimon exclusively entitled to the position of chief executive officer? It is because he has skills, knowledge, and the experience that these people do not have to be doing this task. And so we at Swarms are trying to replicate this with agents, because otherwise, if you don't have an autonomously constructing organizational chart, you have to decide, I want this agent to talk to that agent, then this agent will talk to this one. And that, while it is precise, you do build your org chart manually. You could be like the chairman of the board of directors or something. But it's still mostly a waste of time. You should not be like doing that yourself. It should be autonomous. And so DSO is basically the swarm builds itself to the requirements or to the input task. So if you give it a bunch of documents and you say, analyze, like create a swarm to analyze this patient, it'll create the agents specialize on that patient data. So if you say, create a patient, like if you say a patient has like diabetes, and you say create a swarm for this patient, it'll create a swarm of agents, multiple agents, and then run them, uh, and they'll all be specialized to diabetes in some capacity. You can also provide rules or a constitution. And so the rules is very important because the rules will often decide how this org chart comes into fruition. There was a very famous paper called Constitution by Anthropic. So last year, Anthropic released this, which is basically like it's essentially like a list of rules, and the agents will organize themselves with these rules. And so the dynamic swarm orchestration is kind of like you invest in a company or you invest in one person, and then this one person will build out the team they need for whatever problem is trying to solve. It's essentially like you're a venture capitalist. Let's put it like that. A VC investor will typically invest in a founder, and then this founder will then be responsible for building a team that is most likely to succeed in whatever task they're trying to solve. At least, hopefully, they will be, the most likely to succeed. Now, how did this work? How does this work on an implementation level? And I'll show you how to do it. It's also super easy, okay? It's literally one line of code, but I want to show you how it works so you have a little bit more contextual understanding of what is fundamentally going on here. Um, so we have this feature in the swarm router class. So in the swarm router, if you select swarm underscore type equals auto, it'll choose a swarm out of a list of swarms based off of your input task. And so it'll analyze keywords such as run multiple agents, run these agents sequentially. If you give it keywords, like analyze these documents sequentially, multiple, concurrent. Like if you give it these keywords, it'll automatically select a swarm that is most likely the swarm that you need. And the way that it does this is through you give it a task, right? So you say do this, do that. It'll use it. Well, in our case, we're using a RAG system. So we have a bunch of examples in a vector database, and then we're going to conduct cosine similarity with the task input to find the best possible swarm. In our case, it's only five for simplicity. We have sequential, we have parallel, concurrent, we have collaborative, which is mixture, we have spreadsheet, and then we have agent rearrange. And so if you say analyze these x-ray diagrams sequentially or concurrently, it'll it'll choose this swarm, and then that'll be the one it runs. And then that is a form of dynamic swarm orchestration. It's a very early type of dynamic swarm orchestration. In about a year from now, you'll be able to generate like thousands upon thousands of agents, and then like you wouldn't even need to do, like you wouldn't need to say like do this, do that. Like it'll do all that for you. And so this here is our drag and drop no code interface that we're starting to build. And one of the main features will be this dynamic swarm orchestration capabilities that will allow you to just basically say what type of team you want, if you have any preliminary documents, PDFs, data sources. And then after that, it'll build all the agents that you need with all their tools, with all their RAG systems autonomously, and you won't have to do anything. It's just agents building agents that builds other agents. And so you can imagine this on like here with just one button. You press this, and then you say, I want to build a X-ray diagnosis team, and then it'll build the agents. You'll see a pop up here. Then you go bing, 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 and that would be a very simple way to visualize it. So the way that it works in Swarms right now is, like I said, we have the match type here is powered by the Swarm Matcher, and then the Swarm Matcher uses the Factor database. So it works basically. You give it a problem, goes to the matcher, then we generate an embedding, then we query our vector database for any past experiences with this problem or this keyword, and then we find the most appropriate swarm, matching swarm types, and then it selects the best swarm. And then it will execute the task in the swarm. And that's pretty much it. It uses RAG to conduct cosine similarity on your input problem. In the input problem, if you give it more keywords, it'll tend to gravitate towards whatever swarm is characterized under that keyword. So if you say sequential, step by step, like words like that, it'll select the sequential workflow. If you say words like current, run multiple, do this many times, like it'll choose the concurrent one. If you say collaborative, mixture, it'll use the mixture of agents one. And so yeah, that's pretty much how that works. If you want to see the code, it's available in the main Swarms GitHub, so please check that out, and you can see how it works with greater precision. Does anybody have any questions?
You have a quick question.
Yep.
I know you were saying that the auto prompt generation is better than what a human can typically do, but how do you kind of ensure that the prompts are like high enough quality for system prompts?
That's a good question. So there's a couple of things you could do. Um, the first thing is you can, well, the easiest thing is you can have like a fully automated evaluation system of the system prompt. So you would create the prompt and then you would have some form of a automated test, and then like it would involve testing, evaluation, and then also that would also involve human verified responses. So if you wanted to test this out on a super empirical level, you would have to have a human build a prompt for a task and then instruct an agent to build a prompt for that same task, and then kind of have like a competition and then see who would do best. Otherwise, you can just have like a fully automated evaluation system. Or you can have like human, you can still have a human in the loop. So what I do is I'll typically have the agent generate the prompt, and then I'll just have to make some revisions, which is most often not the case because the prompt is always so good that I simply like this is already like the one for the X-rays. It's already almost too complex for me to work on because I don't know anything about X-ray diagnosis. So how am I gonna like make that better or verify it if I don't even know what the hell like if I don't know anything about X-ray diagnosis? So it's a combination of evaluation systems, human in the loop, and just like prompting, like knowing like optimization, which is also just a form of human in the loop. Does that make sense?
So like the GPT-4, for example, analyzes what the name of the agent is, like financial analyst agent, and then it kind of exhaustively generates a system prompt for it.
Yes.
Yeah. Okay. I think I get it.
Yeah, that's essentially what happens. You could still like you can manipulate the prompt. You can, you could do this, you could do that. Like if you don't like how the prompt that GPT-4 made, you can make it better. You can make it, however you wish. But most often the case that wouldn't even be necessary most often. That's been the case for me. Like if the prompt that the GPT-4 makes is so good, you won't need to make like optimizations. I barely make optimizations to the prompt that it makes because it's already so good.
And it's prompting individually for each agent. It's not like spreading its attention over multiple agent instructions.
What do you mean?
Like, I guess I'm just thinking normally when you prompt an LLM, if you give it a lot of tasks, it's going to put less specificity. But here it's querying GPT-4 for each system prompt separately.
Oh, so you're saying in the case of multiple agents?
Yeah.
So no, that's not the case because I could show you why. So here, what's happening is like if we have 5 agents and we want 5 prompts to be generated for those 5 agents, we are not having one agent build those 5 prompts. We're having all of those agents. We're telling all those agents they should be building all their own prompts. Does that make sense? Like we're turning on a setting within the agent class that I showed you earlier, and then that LLM will then generate the prompt. But we're not here. We're not having one LLM build 5 prompts. Does that make sense?
Yes.
Cool. So, but that would also be a problem. That's actually a pretty big. That's a pretty big problem if you have too much unspecialized data. If you have too much unspecified
like unspecialized data, then you typically get the problem that it's placing too much attention or too less attention, not much attention to the things it should be being paying attention to. And that's what tends to happen if you have a bunch of words, you have a bunch of text inside of a conversation history with an agent. If the conversation runs too long, then especially if it's a random conversation, the agent will simply not do good because it's paying attention to words or phrases that it should not be paying attention to. And that's also another problem if you try to give many tasks to an agent to do. Like if you try to give many tasks to do for an agent to do instead of only giving a one super small unit of work, which is like generate a function, generate a diagnosis, like one unit of work that could be made in 3,000 words, 4,000 words, then it will just not do good at all. And so I also see a lot of people making that mistake as well. But that's why you need multiple agents because, well, first you can't do multiple things with one agent, and then also you also cannot be like you need to specialize your agent if you want it to do good. Otherwise, it'd be a waste of time, and you're just not going to get what you want. Um, so yeah, if you have any other questions, just cut me off and let me know. But as we proceed here, we have the DSO example, and so the DSO example is also super easy. All you have to do is turn on one line of code. um, where is this? Let me make a new file here. So we're going to copy this example that we had before. And so here, you know how we're saying mixture of agents, right? Well, we just delete that and then we just say auto. And then that's it. So now it's going to, so it'll first select a swarm that we need, and then it'll run the agents. So we have that. Now we can try running it. We run that. Oh, we got to move the file. Got to move this here and then run it again. So you see, swarm matcher. Well, actually, it didn't find a swarm, so we got to be more specific. So here we're saying sequentially. Hopefully that will instruct it. So you see, it selected the swarm workflow, but there's still these example from before. I think that was the issue. Let's try it again. If we change this to say concurrently, it should choose the concurrent swarm. So I just said this should be done concurrently, so it picks up. In some cases, you need to be a little bit specific for this to work, but it's still choosing the sequential one, which is not working right now for some reason. Let's try to debug that actually. All right, what is going on here? That might be the issue. Let's see. This feature is actively working in production. Like if you pip install swarms, it will work. The thing is though, I've just been working on a lot of new updates on my computer, and thus my setup is a little bit what's the word for it? Deformed. Yes, that is the word. Let's see if it picks up the spreadsheet one. Yep, still giving us the same error. I think I know how to fix this. Yeah, so sequential one is not working now. So we're going to make a new example for finance. So I'll move that there and then I'll fix that shortly. So now we're going to specialize this swarm to so here I say specialize this swarm to provide ways on saving money on taxes for everyday people. So specialized agents. So we have income analyzer, deduction specialist, investment advisor, tax law expert, planning strategist, tax saving, and yeah. So here we created a swarm. We have tax savings advisor swarm, and then this collaboratively analyzes your financial data for personal tax saving strategies. And then it gives, like, here we have some synthetic data, um, income. So you could give this your actual bank statements and like actual data. Um, and so here it's giving fake data for the time, saying full time employment, 75,000 a year, freelance work. These are like income sources, and then investment income. Renting 2,000 a month, student loan payments 400 a month, contributing to 401k, maybe 5% of your salary, health insurance through employer. I started home-based business this year, donated 2,000 to charities, took online courses for professional development. Though here we could say put all of your results. These agents and now we should hopefully see it working. It's still running on the sequential workflow. Why? It's automatically defaulting towards the sequential workflow, which, I mean, in some cases, and actually in most cases, that would actually be the case, because the sequential swarm is extremely prevalent um, throughout all human communication. Like, I talk to you, you talk to someone else. That's essentially like how most of modern society works. But in this case, it's being way too strict. Let me see if I could make a quick fix. Let's see. Where is this? Oh, yes. So just comment that out. And then let's see what happens. It ran. It's running. And it looks like it did it concurrently as well. Yep. It did it. Let's see some of the results. So these are the prompts it made. It made these prompts for itself. And then here we have the immediate tax saving opportunities. So immediate tax saving opportunity. It declared that it could find, it says increase 401k contributions, contribute more to 401k to reduce taxable income, $1,500. Then you can say itemized deductions on tax return to claim mortgage interest, charitable donations, and medical expenses. $2,000, assuming 10,000 in itemized deductions. Claim home office deductions. Claim home office deductions as a business expense for freelance work. $1,000, assuming $5,000 in home office expenses. Take advantage of education credits. Claim education credits for online course, assuming 2,000 in education expenses. Long-term planning recommendations. Open a SEP IRA. Open a SEP IRA to contribute to retirement savings and reduce taxable income. 3,000. Consider a Roth IRA conversion. Convert traditional IRA to Roth IRA to minimize tax burden in retirement. Develop a retirement savings plan. Create a plan to contribute to retirement accounts and maximize employer matching. And there's a lot of other ways on how to save money on your taxes. Does anybody have an example they would like to try? I don't know how you implemented DSO, but could it have to do with the list of tasks being enumerated, kind of implying a sequential to the LLM that it defaults back to the sequential set? No, so the reason why it wasn't working, the reason why it wasn't working is because, there's two errors, and these errors are not hard to catch. The first error that it was choosing it kept choosing sequential swarm because it thinks that the sequential swarm would be the best for this task. And that so the way, and it is kind of correct. But we were trying to say concurrent, so it should have chose concurrent. So it didn't do good, which is a problem. And the reason why it's doing that is that because the DSO algorithm is still very fresh. It's still very new. And inside the vector database, what's happening is we have a list of examples previously that have worked previously. But if there are no examples for a problem, let's say like analyzing tax strategy, it's not going to select the right swarm because of that. And that's how RAG databases work. If you give it a question and it's never seen this before, it's very unlikely that it's going to choose a piece of data that is related to that. So that's error number one. And then error number two is that I just messed up the sequential workflow by trying to add too many new features. So that was the error. Oh, how do I get out of here? Oh no. Yeah, so DSO is still very new. Still very, very new. And we're still working on it. If you have any ideas, I'd love to hear them. But enabling agents to work with each other is extremely difficult because LLMs natively are not autonomous. GPT-4o1 preview is starting now to become somewhat autonomous. I don't know how the algorithm works. Not many people do, but natively GPT-4 GPT 3.5, and even Claude are not autonomous. So we're trying to make them autonomous, and it's hard, but we're getting there. Now, so I just flipped the switch on the like swarm matcher algorithm. We have a couple of algorithms, and we're going to be continuing to work on new algorithms. So if this is something that you want to work on, please let me know, and let's work together on that. Because, like I said, this is the future of AI. It won't just be like creating one agent that just tries to do everything, which I think too many people now are trying to build one AI that could do everything, which is simply not possible. One AI can only do one thing at a time, and so I just feel very bad for those people. But one AI should only be doing one thing at a time, and it should be super specialized. And so DSO is basically automating the ability for these AIs to self-organize. So it's basically self-organization. Like who should work with who and why should they work with each other? This is a hard problem, and we are the first people ever, to my knowledge, that are working on trying to solve this problem. And hopefully we could be the last. And usher in a future with multi-agent collaboration, and enable you to, like, imagine you as a one person could have like 100,000 agents that are all specialized to anything: programming, your personal, finances, your diet, your workout plan, your sleep plan, like everything you do. And you just have like an army of advisors that help you live your life in the best way possible, which would otherwise cost you, I mean, billions upon billions of dollars. If you wanted a dietitian like in like 1940s, you would have needed like a full-time staff. Or if you wanted a personal, like a finance advisor, you would have to have like unbelievable amounts of money to hire people that were trained in the ways of money and that were good accountants, which most people could just not afford. But now, with AI, the cost of intelligence is plummeting. And now you could have your own team of advisors for food, personal finances, or even for the business. You can have AIs that save thousands of hours every single month by enabling them just to self organize and allow them the freedom to work together on how they see fit. You can have them choose their own teams, um, their own structure, how they communicate, and that's what we're trying to build. And if we can do this successfully and we continue to optimize it, then the cost of living for everybody will get so low that life will be much much easier than it is today. Because now, like, if you don't have a job, especially a good job, like rent prices are soaring, food prices are soaring, water prices are soaring, electricity costs are, like, every good and service most people have are soaring. At some point it becomes unsustainable and a lot of people are going to go homeless, which means everything else is going to get more expensive because now there's less people in the economy that are producing goods and services for the economy, which includes you. And thus, more and more people will end up in this perpetual cycle of extremely high living costs that is simply not sustainable. And I think the only way to solve that problem is by having agents. For example, if you look up according to new projections published today by the AMC, Association of American Medical Colleges, the United States will face a physician shortage of up to 86,000 physicians by 2036. If you look up professions in shortage, America actually right now has a massive labor shortage. Professional and business services. Almost more than half, maybe even half of of job openings are unfilled. Finance, leisure and hospitality, durable goods and manufacturing. And agents can help ease these shortages, which makes your life easier because now you're getting those goods and services that you needed, such as food. And if you're at a business, then business services and whatnot. How do I get out of this screen? So yeah, we're still working on it. We're still making it better. And I'll be actually, so today I'm going to be releasing a new update with a bunch of bug fixes and new improvements. So pretty soon you can get that update just by running this in your terminal. Just go here and you go boom. And then you have the new swarms. And that's it. That's been the culmination of my workshop today. If you have any questions, let me know. And I'll be very delighted to answer them.
What particular area you're talking about? Dynamic swarms orchestration. What I guess is the most imminent problem to work on?
The algorithm. It's basically it's basically a search algorithm. You're searching for where the hell is this workshop? So you're basically searching. You're searching for the people that are best specialized, the agents that are most specialized for a given problem. Like Jamie Dimon. So Jamie Dimon is the CEO of JP Morgan because he knows how to grow and scale banks. That's what he's done all of his career. He scaled Citibank. He also did another bank in Chicago that I forgot the name of. He is just really good at operating banks. Whereas these people are more specialized for analyzing the finances of a bank, analyzing the risk of a bank. So he has experience in leading banks. Jamie Dimon has experience in leading banks. So we have to basically do the same thing. We have to have a search algorithm that is searching through a list of agents and then basically prioritizing how we should execute those agents. Does that make sense?
Yeah.
So the way that we're doing it now And I can send you the link, the code file where all the code is for this, so that you can give it to Claude, and you can have a conversation with it, and you know do whatever you wish, learn about how it works and whatnot. But yeah, this is essentially how DSO works now. Like I said, it's still very infant, and there's so many improvements to make. But and this so DSO will be coming to our drag and drop no code platform that we've been working on. So here is still manual. You have to add your agents, manually, bing, bada, boom. Um, you have to add them all individually, manually. But pretty soon you won't need to do that. You'll be able to generate the agents autonomously, and then you'll also be able to dynamically specify which type, like what type of execution do you want. Do you want sequential? Do you want hierarchical? Like which one do you want? Um, and so that feature will be coming to our drag and drop no code platform pretty soon. And this is free for now, by the way. You can get started with the drag and drop no code swarms platform right now. I dropped the link in the or I'll drop it now.
Thank you.
Yep. All right. I'm gonna take a short break. I'm a little bit tired. I've been trying to solve this problem now all weekend, amongst many other things. So I'll be back in about like 5 minutes if anybody wants to ask me any more questions. And then after that, I'll get back onto fixing the bugs that I've experienced during this presentation, and then solve those, and then also work on improving the DSO. All right, ladies and gentlemen, I have returned. Yes, I am here. I am back. Another day in the life in the swamps.